Okay, so this is from section 4.2 in the David Lippman book, and we're going to talk about ending behavior of some exponential functions. So for this first one, this is out of that yellow notes packet, at least from in the fall of 2017. It was a yellow notes packet at Oxbow. I'm looking at problem number 23. And for that function, I'm seeing a horizontal asymptote at -1. So that tells me that this graph is going to look something like this. Here's my XY axis. I know there's a horizontal asymptote at y equals -1. I'm seeing an exponential growth function that's been reflected around the x-axis because of the -5. So this is looking something like, and well, let's get a little more specific. I know the y-intercept is going to be at -6, because if I substitute in 0 for x, that becomes 4 to the 0 is 1, times -5 is -5, and then minus 1 more is -6. If this is -1, let's see, 1, 2, 3, 4, 5, 6. So that crossed the x-axis somewhere down here. So this graph, being exponential growth function, normally it would look like this. And since it's been reflected around the x-axis, it's going to look something like this. So this tells me as x approaches -infinity, the graph is approaching that horizontal asymptote. So y approaches -1. So let me do it in arrow notation. And as x approaches positive infinity, this function heads down to -infinity. And that's that one. Okay, so now if we look at number 25, I see a transformation of a y equals 1/2 to the x, or y equals 2 to the -x. I see a horizontal asymptote of -2. So that, if you think about what we just did, what I just showed you with number 23, I know it has a horizontal asymptote of -2. Because this is a decay function, normally those come swooping down like this, right? If we think about the horizontal asymptote, or the y-intercept, let's see, if x equals 0, that's going to become 3 minus 2 is -1. So I'm pretty close. We'll make that be -1. And all they're really asking us to do is the ending behavior. So as x approaches -infinity, what's happening to this graph? As x goes, let's see, can I get a pointer going here? As x goes out to -infinity, y is getting larger and larger and larger. So y approaches positive infinity. Oops, I got to get my mouse back here. And as x approaches positive infinity, this graph is getting closer and closer to the horizontal asymptote of y equals -2. So y is approaching -2. Okay, how about this one? Let's think about this one without graphing it. Or maybe we do want to graph it. The negative exponent tells me that I can take the reciprocal of the 4, make it 1/4, and that lets me see that this is indeed a decay equation. I see a horizontal asymptote of y equals 2, so let me clear this off a little bit. So I know that this looks something like, see, it's got a horizontal asymptote of y equals 2. It's a decay equation, so it's going to come swooping down. That would make, if I substitute in 0 for x, that's going to give me 1/4 to the 0 is 1, times 3 is 3, plus 2 is 5. So 3, 4, 5. So it crosses like this. It's a decay equation, so it looks something like this. I had a little more room, I'd make that look a little more swoopy. So as x approaches negative infinity, what's happening to y? I hope you said it's approaching positive infinity. As x approaches positive infinity, what's happening to y? And I hope you said it's approaching that y asymptote of y equals 2. So y approaches 2. And it's that easy. So now what about if I change gears a little bit here and I ask you, let's see, I give you some information about the graph, about the function. What if I tell you as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches 2. And it's a reflection, or it's a transformation of y equal, of the equation y equals 3 to the x. So let's think about what's happening here. I know it's got a horizontal asymptote of y equals 2 because right here, as I go out to infinity, y is going to approach positive 2. So I know this is happening. So I know it's either coming like this, or it's coming like this. It's got to be like that. So it could be a translation. It could be a reflection of y equals 1/3. It looks like a decay equation. So it looks like it could be. A translation of y equals 1/3 to the x, because those look like, this certainly looks like a decay equation, and that would look like a reflected decay equation. So then they tell me as x, let's use this other factoid, as y approaches negative infinity, as x approaches negative infinity, y approaches negative infinity. So this one's out because that's headed up to positive infinity. So I'm seeing this equation right here. That's the graph I'm looking at, in which case this is y equals 1/3 to the x. Notice that's like x to the negative 3. I mean, 3 to the negative x. And then this has to be reflected around the y-axis, so this would have to, around the x-axis, that would have to have a negative in front of it. Now I could put a number in front of there, but without a lot more information, that's what that's going to look like. Okay, so that's one way to deal with that. Let's try something else. Let's try a different one. How about if I tell you some function has a y-intercept of 0, so 0, 0, passes through 0, 0. I know it's a translation of y equals 3 to the x. I know as x approaches negative infinity, y approaches, let's see, y would approach 2. As x approaches positive infinity, y would approach negative infinity. Let's try to figure this out. So I know it's got a horizontal asymptote of y equals 2 because way out at infinity, this graph is approaching 2. I know as x approaches x at negative infinity. So this is either going to look like this, or it's going to look like this. I do know it crosses through 0, 0, so that kind of locks that in. It's got to be that graph. This one would never cross through 0, 0. So let me erase that. Does that give me information? Let's see, as x approaches positive infinity, y approaches negative infinity. So some things I can talk about. I know that y equals a times 3 to the x plus 2, because I've got to get that horizontal asymptote. I know that it crosses the point 0, 0, so 0 equals a times 3 to the 0 plus 2. So if I subtract 2 from both sides, that gives me negative 2 equals a times 1. So as you can see, this equation right here matches all those pieces. Okay, let's do one more, and then I'll figure that'd be good enough, and you can either do the quiz or do some more problems like this. This all came out of section 4.2. So let me clean this up. So I know I've got a function that's a translation of y equals 4 to the x. I know that as x approaches negative infinity, y would approach positive infinity. As x approaches positive infinity, y approaches 1. I know this function has a y-intercept of 0, 5. Let's figure out what it looks like, and then try to write an equation for it. Though you already kind of know what the answer is. But pretend I'm not looking at that. So it has a y-intercept. Well, it has a horizontal asymptotal y equals 1. So there's that. I know it crosses through 0, 5. As x approaches negative infinity, y approaches, so it's gotta head like this, right? Crosses there, and then it goes like this. So I'm seeing exponential decay function. So I know it won't be y equals 4 to the x. It'll be y equals 1/4, or I could say x to the negative 4 to the negative x. I'd like to keep my exponent positive if I can. I know it has a horizontal asymptote of y equals 1. And there's some stretch factor here probably. We got to see if we got to get it to pass through that 0.05. So does 5 equal a times 1/4 to the 0 plus 1? Well, let's see. 1/4 to 0 is 1, so that's a. And if I subtract 1 from both sides, a equals 4. So this should be a 4 right here. And if we go down and look where I came up with this problem, you see that answer? So hopefully that helps you write these kind of equations when I give you facts about them.